A real image is an image formed by a lens where light rays from an object converge on the other side of the lens. Remember that we use lenses to form images by refracting light rays from an object so they converge or appear to converge elsewhere. One type of lens is a convex lens. This lens curves outwards and will cause parallel rays to diverge. Let's suppose we've placed an object on one side of the lens. We'll assume this is just something that extends up from this line through the centre of the lens. In a ray diagram, we could just represent this object as an arrow pointing upwards to a certain height. Now let's suppose we've drawn a ray diagram and found the paths of these three key rays. As we can see, the rays will converge at this point here. So this is where our image forms. As this point is on the other side of the lens and the rays are actually converging, we can identify this as a real image. But what else can we say about this image? An inverted image is formed when rays from a point on the object converge or appear to converge on the opposite side of the principal axis. So here we've already drawn in the principal axis as the line through the centre of the lens which the object is extending from. Remember that this is the line along which rays will not refract at all. The image we found previously is an example of an inverted image. How can we tell this? Well, we see that our object is standing above the principal axis. This means that the rays in our ray diagram all start above the axis. But then they converge at this point below the axis. This tells us that the top of the image is on the opposite side of the principal axis, which means it's defined as an inverted image. But how does this affect the image? Well, as we can see, the image is now upside down in comparison to the object. For your exam, though, you can just define an inverted image based on where the rays converge in relation to the principal axis. Also, don't get confused and think that all real images are also inverted, even though that's what you'll see for the types of lenses you study at GCSE. Now let's go back to the fact that this is also a real image. How would we see this kind of image? A real image can be viewed by holding a screen at the point where the light rays converge. Now this is often used in camera lenses and projectors. Here's a simple diagram showing how this works. Here we see an object in front of a lens, with a screen on the other side. Light from both ends of the object will refract through the lens. As a result, the light rays from each end will reconverge on the screen. Furthermore, the rays from the top of the image converge at the bottom of the screen and vice versa. So this forms a real inverted image. But are all images formed by lenses real? Well, a virtual image is an image formed by a lens where light rays from an object diverge but appear to converge on the same side of the lens. Let's see how this works using a concave lens. This type of lens curves inwards and will cause parallel rays to diverge. So how would the lens form an image of this object? Well, this time, if we start drawing the ray diagram, we see that the rays will diverge after passing through the lens. This means they can't converge on this side of the lens, so the image formed can't be real. Instead, we complete the diagram by tracing the path of this ray back through the lens. As we can see, there are two lines crossing here. This means that the rays appear to converge here, which forms an image. As the rays aren't actually converging, and the object and the image are on the same side of the lens, this is a virtual image. But is this also an inverted image, or something else? An upright image is formed when the rays from a point on the object converge or appear to converge on the same side of the principal axis. So let's look back at this virtual image. Here we see it extends above the principal axis, just like this object. As the origin of the rays and the point where they appear to converge are on the same side of the axis, this is an upright image. So how would this image look? Well, as we can see, it's not upside down like the inverted image. It has the same orientation as the object, and only the size has changed. For your exam, make sure you can recall all of these definitions. You should also be able to identify what type of image has been produced in a ray diagram and explain why. And again, not all virtual images are upright, so make sure you know these definitions separately. Now, since this image is virtual and not real, does that affect how we can view it? Well, virtual images can only be viewed by an observer on the other side of the lens. This is often used in telescopes and magnifying glasses. So suppose we have someone looking through the lens from the other side. Our eyes work by telling our brains about various light rays and the directions they're travelling in. Our brains then trace these rays back to figure out where they originate from. In this case, as we look through the lens, we would only see the image, not the object. This is because the lens has tricked our brain into thinking that these light rays converge here, rather than at the object. This is similar to how we're tricked into seeing objects in a mirror. But why can we only view the object this way? Well, it's because the light rays aren't really converging here. So if we were to hold a screen here, then nothing would appear. Now, you won't be expected to explain how to view images in this much detail for your exam, but you should still have a general understanding of the differences between viewing real and virtual images.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!